welcome to today's lecture. Today's lecture is all about what? Bonding. Objectives. Firstly, I'm going to start by doing an introduction to bonding. After that, I'm going to teach you about the types of bonding. Lastly, I'm going to do some examination questions that fall under what? Bonding. Now let's look at this interesting part called bonding. So bonding can be anything, but under chemistry we're simply talking about bonding of what? Atoms. What is bonding? By definition, bonding is chemical combination of two or more atoms. So when two or more atoms combine chemically, that's what we're calling what? Bonding. Note that compounds and molecules result from what? Chemical bonding. So when chemical bonding occurs, the products we get are compounds and what? Molecules. Compounds are simply substances formed by two or more different types of what? Elements. Example, sodium chloride is formed from two different types of what? Elements. While molecules, these are simply pure substances that are formed or composed of the same types of what? Atoms. Example, oxygen and what? Hydrogen. So when you look at hydrogen, there is a 2 down there. It's formed from the same types of what? Atoms. Note that only outermost shell electrons take part in what? Bonding. So the only electrons that take part in bonding, they are electrons that are found in the outermost shell of any what? Atom. So these outermost shell electrons are the ones that participate in what? Bonding. Atoms are held together by the forces of what? Attraction or what? Bonds. Note that for any bonding to occur, there must be a force of what? Attraction between the what? The atoms. A bond is a force of attraction between what? Atoms. And this is the thing that makes bonding to what? To occur or to be there. Without the force of attraction, there can't be bonding. Okay, now that we know what bonding is, we need to know why do atoms what? Bond. Or why do atoms form bonds? So atoms form bonds in order to be stable. It's for their stability. Note that atoms react with one another in order to acquire full outermost shells like those of what? Noble gases. These noble gases we are seeing, they are group 8 elements of the periodic table, and they are what? Stable gases. They do not lose or gain what? Electrons, because they are stable. They obey octet rule, unlike helium, which obeys duplex what? Loop. So the reason why atoms react is because they want to be stable like what? Noble what? Gases. Or they want to acquire a full outermost shells like those of what? Noble what? Gases. So example of an element that is found in group 8 of the periodic table, which is part of the noble gases, is what? Neon. So neon has a mass number of 20 and has the atomic number of what? 10. So if we do the electronic configuration for neon, we find that the first shell has what? 2 electrons. Second shell should have how many electrons? 8. You subtract this from that, we're going to get what? 8 electrons. So this one, there are 8 electrons. And if you can remember octet rule, that's if you have watched the video on electronic configuration. Octet rule should have how many electrons? First should have how many electrons? 2. Second, 8. Third, what? 8. Have you seen this? It's the same as here. So this one, it's stable and it's obeying what? Octet rule. So this neon can't lose or gain what? Electrons, because it's what? Stable. So one of the reasons why atoms react or bond is to acquire a full outermost shell like what? Noble gases, to acquire the full electrons, like obeying what? The octet what? Loop. So for example, lithium, it's a metal. It has 7 as the mass number and 3 as the atomic what? Number. So let's do the electronic configuration for this. So octet rule is saying first you should have how many electrons? 2. 2 is subtract from 3, you're going to have what? 1. Here we're not having something like 8, because second shell according to octet rule should have how many electrons? 8, but it's having 1. So this one, it's a metal, so meaning lithium should lose this electron so that it can be what? Stable. So this one can react with other elements or can bond with other elements in order for it to acquire a full outermost what? Shell, like what? Noble what? Gases. I'm sure that's what clear to you. Okay, now let's look at this interesting part, types of what? Bonding. So there are three types of bonding, namely ionic bonding, covalent bonding, and metallic bonding. So let's start with ionic what? Bonding. So the alternative term for ionic bonding is what? Electrovalent what? Bonding. So what is electrovalent bonding or ionic bonding? So ionic bonding involves the transfer of electrons from a metal to a what? Non-metal. Note that a metal loses what? Electrons, while a non-metal gains what? Electrons. Formation of ions. So this part is very much important under ionic what? Bonding, because ionic bonding involves interaction of what? Positively charged ions with a negative charged what? Ions. So there are two types of ions, namely positive ions, which we call cation, and negative ions, which we call what? Anions. So now let's look at positive what? Ions. So metals form positive what? Ions, meaning metals lose what? Electrons. So when metals form positive ions, it's just an indication that they lose what? Electrons. So when metals lose electrons, they form positively charged what? Ions. Examples of positively charged ions are sodium ion, like this. This plus you are seeing here, it's an ion. It's an indication that sodium loses what? One electron, and it's placed in group 1. So all group 1 elements, they lose what? One electron. Same with what? Lithium. So when you see on a periodic table, lithium and sodium, they are placed in the same group of the periodic table. That's the reason why they are having this plus 1, which means they lose one electron because they are metals. When you look at aluminium, these three are seeing plus. This 3 is a charge, while this is an ion. So aluminium loses 3 electrons. Calcium is in group 2, so it loses how many electrons? 2 electrons, for it to be what? Stable. So an example how these things are formed is like this. So this is an ion. So sodium atom is like this. So it's in group 1. So I'll just indicate like this as an electron, or I do this, but this is same as 1. It's okay. So this, it will turn into what? An ion, which will form, since sodium is losing what? One electron. So even if I don't indicate 1, this is just same as 1. So it will be like this. So this is an ion. This is a sodium ion, while this is a sodium what? Atom. Same applies to this aluminium. Aluminium, it's a metal like this. The symbol is Al. So it loses how many electrons? 3 electrons to form this plus. So it looks like this now when it has what? Lost what? Electrons. So same applies with calcium, same thing. So calcium, the symbol is Ca, like that. So it loses how many electrons? It's in group 2, so it loses 2 electrons to form a what? An ion, a positive charged what? Ions, which looks like this. Say 2 on top, like that. So you need to know this. This is very much what? Important. Okay, now let's do an example so that you can understand what I'm doing. So the question is saying illustrate the formation of ions of the following given what? Atoms. So I'm going to illustrate for sodium, magnesium, and then for aluminium and lithium you can do it on your own. So let's start with sodium. So sodium now, let's try to illustrate. So first and foremost, you need to know the symbol for sodium, which is Na. The mass number is 23 and the atomic number is what? 11. We need to know this. This is very much what? Important. So another thing, we're not supposed to forget the octet rule. First shell should have how many electrons? 2, second 8, third what? 8. So this thing is very much what? Important, even under what? Bonding. So let's start now. So sodium, it's Na, like this. First shell should have how many electrons? 2. So we're going to use this atomic number as in here. So 2 electrons first shell, you subtract from 11. So, and then second shell should have how many electrons? 8. So we have already subtracted 2 from 11. We remain with how many? 9. So second shell should have how many electrons? 8. So 2, 4, 6, 8. So this second shell is what? Stable. And then let's do the other one, because we remain with 1 electron now. Remain with 1. And then that one we can put it any at any point. So this is 1 electron. But under octet true, third shell should have how many electrons? 3 electrons. But this third shell is having 1 electron. So sodium, since it's a metal, should lose this electron for it to become what? Stable. So when this electron is lost, we're going to have 2 electrons which are what? Stable, which are obeying the what? The octet what? Loop. So it's going to be like this. We need to show how sodium will look after what? Losing. So when sodium loses this electron, this shell would disappear, and sodium will remain with how many shells? 2. So we write Na here, like that, and then you write another second one, like that too, and then like that. So note that the other shell has disappeared because it's losing what? 1 electron. So note that it's losing, because it's a metal, it's losing 1 what? Electron. And then you need to put this to my brackets like that. So it's losing what? 1 electron. So here you're going to write positive like that. Note that this is a sodium ion. This is sodium ion. The symbol is what? Na plus, like that, meaning it has lost what? 1 electron. And then this is sodium, this is sodium atom. So have you seen the difference between a sodium atom and an ion? And then the symbol is just Na, like that. And then the electronic configuration for this one, so the electronic configuration is what? 2, 8, and then 1, like that. What about this one? It's an ion. Electronic configuration for an ion. They can even ask you that. So first shell is having what? 2. Second what? 8. There's also what? An electron. So I'm sure for this one it's clear. So let's do for magnesium now. So the same thing. Okay, so we're going to do the same thing from doing to magnesium. So let's start with the symbol. So the symbol for magnesium, it's what? Mg. The mass number is what? 24, while the atomic number is what? 12. So you need to be familiar with what? The periodic table. So let's start now. So the symbol for magnesium is what? Mg. Then the first shell should have how many electrons according to octet true? 2 electrons. So it's 2, you subtract from 12, you remain with 10. And then the second shell should have how many electrons? Should have about 8 electrons according to octet true. So I'm going to write 8 electrons there. So 2, 4, 6, 8. So for this second shell is stable according to octet true, it's having 8 electrons. Now 8 plus this 2, it's 10. So you subtract from this, you remain with the other what? 2 what? Electrons. So in the third shell, we remain with how many electrons? 2. You can place them anywhere if you want, here, anywhere. So 2 electrons. Now according to octet true, first shell 2 electrons, second 2, third, second 8, third 8. Now in this third shell, are these electrons here 8? No, they are 2. So meaning magnesium is not stable. In this third shell, we must have about 8 electrons according to octet true, but we have 2, meaning magnesium is not stable. So magnesium should lose these 2 electrons so that it can remain with these 2 other stable shells which are obeying octet loop. So magnesium is going to lose 2 electrons. So it's losing 2 electrons. Don't forget that metals lose what? Electrons, while non-metals gain. So this side I'm going to show you how this magnesium atom will look after losing these 2 electrons. So that this third shell will disappear. We're going to remain with these two stable shells. So this side I'm going to illustrate or show how this magnesium will look. So it's having 2, the first one, then the second one it's having what, 8 electrons. So and then this one is even, so magnesium, it's losing how many electrons, 2. So here on top we're going to show 2 plus. So this 2 plus is just showing that it's losing how many electrons, 2 electrons. And don't forget that metals form positive charged what, ions. So this one here we call it magnesium what, ion. So this is what magnesium ion is. And then this one is magnesium what, atom, magnesium atom. And then the symbol for this one is just Mg. And then the symbol for an ion is what, Mg2 plus, meaning this one just lost how many electrons, 2. Then the electron configuration for magnesium ion is what, first shell is having how many electrons, 2. The second shell is having what, 8. It has lost 2 electrons. So this is the electron configuration. Then for magnesium atom is what, first shell is having 2, second 8, third 2 electrons. So have you seen the difference between magnesium atom and magnesium ion? So they can even ask you to write the electron configuration for magnesium what, ion, this one. So this is how you do it, and you do the other last 2. You can do it on your own. So now let's look at negative what, ions, and I'm sure you're clear about the positive ions. So non-metals form negative ions, meaning they gain what, electrons. If you can remember clearly what I said about the positive ions, I said metals form positive ions, meaning that they lose what, electrons. So this is just the opposite of the other. And then when non-metals gain electrons, they form negative what, charged what, ions. And then for metals, if metals lose electrons, they form positive charged what, electrons. And I'm sure you're clear on that one. So if you know for negative ions, it's just the opposite for the positive what, ions. Examples of negative recharged what, ions. We have chloride, this is an ion. We have fluoride, this one, and we have nitride, and we have what, oxide. So for chloride and nitride, these things are coming from group what, 7. So this chloride is coming from chlorine what, atom. This fluoride you're seeing is coming from what, fluorine what, atom. So these two, they are in the same group. That's why you're seeing -1 there as a power, -1 as a power. So this is a sign that they gain 1 electron for them to be what, stable. They gain what, 1 electron. And these two are in group what, 7. So how do I know the number of electrons group 7 elements should gain for them to become stable? We need to know that the total number of groups is what, 8 on the periodic table. And then chlorine and fluorine are in group what, 7 of the periodic table. They are in group 7. So for me to know the number of electrons chlorine and fluorine should gain, I should subtract this 7 from the total number of groups, which is 8. So it's 1. So this thing you are seeing here, that's where it's coming from. So this one was like this. Chlorine, the symbol for chlorine is that one, and then it's losing 1. It's gaining 1 electron. It's gaining 1 electron like that. And then it's going to form a chloride what, ion, which will look like this. It has gained 1. You can't write 1 in front like that, or even just write in this for electrons, okay, without this one in. And then same applies with what, fluoride. So fluoride, there was something like fluorine like that, and then 1 electron. It's gaining 1 electron to form this fluoride. So this is an atom, this is fluoride. This is chlorine atom, this is chloride ion. And then when we come to this one, where is this 3 coming from? Note that nitrogen is in group what? 5. Nitrogen is in group 5 of the periodic table. So how do I know the number of electrons nitrogen should gain for it to become stable? I need to subtract this 5 from 8, which is going to give me 3. So this is a 3 you are seeing here. So nitrogen should gain 3 electrons for it to become what? Stable. So nitrite is just an ion for nitrogen. So nitrogen, the symbol is Na. So it's gaining 3 electrons to form nitrite ion like this. So this means that this is an ion for nitrogen, and we call it nitrite, and it must, so it means gaining 3 what? Electrons for it to become what? Stable. So you need to know this, and then you can do that for oxide. Oxide is coming from what? Oxygen. Okay, now let's do an example so that you can understand what I'm from doing there. So question is saying illustrate the formation of ions from the following given what? Atom. So we have in chlorine, oxygen, nitrogen, and what? Carbon. So we want the ions, formation of ions from these atoms. So let's do it, and I'm going to do for chlorine and oxygen. Then for nitrogen and carbon, you can do it on your own. So chlorine. So chlorine is in group what? 7 of the periodic table. So we need to know the symbol for chlorine. It's Cl like that, and then it has the mass number of 35.5 like that, and then it has 17 down like that. And note that these are non-metals, so they gain what? Electrons. So let's start with the symbol for chlorine. So chlorine has Cl like that. According to octet rule, the same thing, it should have how many electrons? 2 electrons first. Then second should have how many electrons? 8 electrons. So from 17 I've already subtracted 2, I'm remaining with what? 15. So second should have how many? 8 electrons. 8 electrons. So I'm sure 8 electrons are done. So 2, 4, 6, 8. So plus this 2 inside, that's 10. 10 you subtract from 17, we're remaining with 7 electrons. But third shell should have how many electrons? 8 electrons. So we're having 2, 4, 6, 7. But this last shell, it's not stable because it should have how many electrons? 8. Remember octet rule. First shell 2 electrons, second 8, third what? 8 electrons. So the last shell is not stable. So meaning chlorine should gain 1 electron for it to become what? Stable. So it's a non-metal, it should gain 1 electron so that it can make it work to what? 8. So this side I'm going to show how chlorine will look after gaining what? 1 electron. So here chlorine is gaining 1 electron. So let me show how chlorine will look after gaining Cl. So 2 second shell, 2, 4, 6, 8, and there is a last shell here like this. So 2, 4, 6, 7. Have you seen that? Now here I'm going to show how chlorine will look after gaining. So chlorine should gain what? 1 electron. So 1 electron, I'm going to do it like this. It should gain 1 electron so that this one can obey the octet rule. It should have how many electrons? 8, not what? 7. So this side now it's gaining what? 1. So here I'm going to write just -1, like just negative like this, same as 1, not 1 negative, just this, which means it's gaining what? 1 electron. So note that this is we call this one as chloride ion. This is chloride now, chloride ion. The symbol is what? Like this. And then the electronic configuration for this one, first shell is having how many? 2, second 8, third what? 8. Just like that. and I'm sure you are clear on this one. Now let's come to this. So this one is chlorine atom. This one is chlorine atom. And then the symbol is just Cl like that. Electronic configuration for chlorine is first choice having 2, second 8, third what? 7. So have you seen this 7 here? There is 8. So this one, it has gained 1 electron. So you need to know this. This is what very much what important. So okay, now let's do for oxygen. So we need to know the symbol for oxygen, which is O, and oxygen has the mass number of what? 16, and it has the atomic number of what? 8, like this. So you need to know this, which is very much important. So let's start now. So I'm start with the symbol for oxygen, which is O. Then first shell should have how many electrons? 2 electrons. So I subtract 2. I've used 2 from 8. I'm remaining with what? 6 electrons. 6 electrons. So I'm going to have something like 2, 4, 6. So I'm done. So 2, 4, 6, 8. I'm done with what? 8 electrons for what? Oxygen. Now this second shell should have how many electrons according to octet rule? 8 electrons. Remember, octet rule. First shell 2, second 8, third what? 8. First shell is satisfied with 2 electrons, but second shell, is it having 8 electrons, having 6? So meaning oxygen should gain how many electrons? 2. So there are 2 electrons missing here. So I'm supposed to show how oxygen will look after gaining what? Electrons. So oxygen must gain 2 electrons to make it what? 8 in this second what? Shell. So oxygen must gain 2. Must gain what? 2 electrons for it to become what? Stable. So I'm going to write how oxygen will look after gaining, like this. So then like that, 2 there, 2 here, and then 2 here. So oxygen, it's gaining how many? 2. It must gain 2 electrons. So I'm going to show 2 electrons here, like this, like this. So it must gain 2 electrons. And then this one, it's even satisfied. It has now obeyed the what? The octet rule, because second shell should have how many electrons? 8, not 6. So oxygen must gain 2 electrons for it to become what? Stable. So here I'm going to write 2 negative, and then note that this is an oxide ion. The symbol is, I'm sure you have seen something like that. And then the electronic configuration, this just means that it's gaining 2 electrons. So the electronic configuration for this oxide ion, first you will have 2 electrons, second 8. But let's come to this we call it what? Oxygen what? Atom. So this is an atom, and then the symbol is just O, like that. And then the electronic configuration for oxygen, first you have 2, second 6. Sorry, second is 6, not 8. Second is what? 6, not 8. So, and I'm sure you're clear about these things. Hope it's clear here. And then you can do for nitrogen and what? Carbon. Okay, now let's do ionic what? Bonding, or let's try to illustrate the formation of ionic bonding between the following what? Ionic what? Compounds. So the main reason I was trying to show you the illustration for the formation of ions we're from doing for the negative and the positive ions, it's for you to be clear on ionic what? Bonding, because whatever we are from doing there, it's a thing that we're going to do here. So remember, ionic bonding is a type of bonding that exists between a metal and a non-what? Metal. It involves transferring of electrons from metals to what? Non-metals. So the question is saying illustrate the formation of ionic bonding between the ionic what? Compounds. So for A, we have in sodium what? Chloride. So this is sodium and this is chloride. So sodium is a metal, while this chlorine is a non-metal. So have you seen? Sodium will lose an electron to give this chlorine. So as sodium is losing, to be stable, and as chlorine is going to gain that electron, it's going to become what? Stable. So this type of bonding exists between a metal and what? A non-metal. So let's try to do this type of what? Illustration, so that you can see how this thing are what? Done. So let's start with sodium what? Chloride. So the same thing, sodium chloride. So I'll start with sodium. You know that sodium is what? Na, and it has 23 on top, and it has 11 down as the atomic number. And then chlorine has a 35.5, and it has a 17 what? Down, like that. So what do you do now? We start with sodium. We do the same thing we're from doing here, and sodium it's a metal, don't forget. So first shell should have how many electrons? 2 electrons. So 2 we subtract from 11, we remain with what? 9. So here second shell should have how many electrons? 8. So 2, 4, 6, 8, like that. And then 8 plus this to 10. We subtract 10 from 11, we're going to remain with 1 electron, which is in the outermost what? Shell. So sodium is having 1, like that. So sodium it's a metal, it's going to lose an electron, like that. So it's going to lose that 1 electron. So here I'm going to draw for chlorine. So chlorine is a non-metal and it gains electrons. So chlorine is Cl. So I'm going to do this. Now I'm going to differentiate. This time I'm not going to do the crosses, I'm going to do the what? The dots, like this, to differentiate. So first shell 2. So 2 we subtract from 17, remains 15. And then second shell should have how many? 8 electrons. So 4, 6, 8, like that. And then how many are we? So 8 plus this to 10. 10 you subtract from 17, you're remaining with 7 electrons. So 2, 4, 6, 8, also 2, 4, 6, then 7 here. So have you seen this one? It's not stable. Chlorine, it's a non-metal, must gain 1 electron, because according to electronic configuration, third shell should have how many electrons? 8, but it's having 7. So it's going to gain 1 from a metal, like this. And then this sodium, this third shell, it should have how many electrons? 8, but this metal, it's going to lose this so that it can become stable. So that's the reason for bonding. So here we're going to illustrate this side. We're going to show how these two will look after losing what? After, when we're going to show for sodium after losing, how it's going to be, and then I'm going to show how chlorine will look after gaining. So let me start for sodium. The same thing that we're doing. So sodium has lost that shell because it has lost an electron. So I'm going to do this. So there sodium is remaining with how many shells? 2. It's a metal, so don't forget that. So like that, and then it has lost what? 1. So don't forget that it has lost 1. So I'm going to write a positive here, positive, to show that it has lost what? 1 electron. And then I'm going to show for magnesium, so for chlorine, how it's going to look after what? Gaining. After gaining, how is it going to look? So so chlorine, the symbol is like this. First shell 2, second shell 8, like that. It's having 3. So this one has gained what? 1. So it's having 1 last outermost what? Shell. So 2, 4, 6, and then it has gained what? 1. Just have to show. So that one you need to show it by negative. So therefore this is what we call sodium what? Chloride, like that. So by doing this, then you're done. You have illustrated the ionic bonding between sodium and what? Chloride. And I'm sure it's very simple, and you know how to go about it. So let's do for magnesium. So magnesium oxide, so it's between magnesium, which is a metal, and oxygen, which is a non-metal. So magnesium is what? Mg, which has 24 on top, and it has 12 what? Down. And then oxygen has 16 as the mass number, and it has 8 as the what? Atomic number. So Mg, let's start with metal. Mg, so it has first shell should have how many? 2. Subtract the main with 10. Second shell should have how many? 8 electrons. 8 electrons. So together with this one is 10. So 8 plus 2, 10. Subtract 10 from 12, we're going to remain with 2 electrons in the outermost what? Shell. And this is a metal. So here, this stage shell, according to octet rule, it should have 8 electrons. But this magnesium is having how many electrons? 2 in the outermost shell. So magnesium should lose 2 electrons for it to become what? Stable. So it will lose these 2 electrons. So let me show for oxygen. So oxygen, the symbol O, and then I'm going to differentiate by the dots. So from 8 I subtract to remain with what? 6. Remain with 6. So 2, 4, 6. Have you seen? So oxygen is a non-metal. So oxygen should gain how many electrons? 2 electrons. And these 2 electrons are coming from where? From magnesium. Like that. So this one has gained, and this second shell, it has become stable by gaining. So oxygen has become what? Stable. Now what about magnesium? Magnesium has become stable by losing these 2. So now let me show this side how these things will look after losing. So I will show how magnesium will look after losing, and I will show how oxygen will look after what? Gaining. So Mg, like this. So first shell is having 2. So note that magnesium has lost the third shell. Like that, like that, like that. And then magnesium has lost how many electrons? 2. So we're going to write 2 positive there. Just like that. And then let's show for oxygen this side. So oxygen, the symbol O, and then just do the dots, differentiate from that one of the metal, and then 2, 4, 6, and then you show how it gained these 2 electrons, like that. Now this one for gaining, we write 2 negative to show it has gained, and then this is magnesium what? Oxide. So just by doing this, then you have illustrated the ionic what? Bonding between magnesium what? Oxide. Okay, now let me do for calcium chloride. So calcium chloride is involving calcium, which is a metal, which is from group 2, and chlorine from group 7. So let's do it now. So calcium, it has the mass number of 40, the atomic number of what? 20. And then chlorine, it has the mass number of 35.5, and it has the 17 as the what? Atomic number. So let's start with the calcium. Don't forget to illustrating the ionic bonding between calcium and what? Chlorine. So calcium, Ca like that, that's the symbol. And then first shell should have how many electrons? 2 electrons. And then second shell should have how many electrons? 8. So 2 you subtract from 20, you're going to remain with 18 electrons. So here second shell should have how many electrons? 8 electrons, like that. So here 8 plus this 2 inside, we're having 10. 10 you subtract from 20, you remain with the other 10 what? Electrons. But third shell should have how many electrons? 8 as well, according to octet what? Rule. So 2, 4, 6, 8, like that. So 8 plus this 8, 16 plus this 2, 18. 18 subtract from 20 remain with the last 2 electrons. So calcium has so many shells. 7 how many shells? 1, 2, 3, 4 shells. So we remain with 2 electrons. So you can place them anywhere. So these are 2 electrons that are remaining in the outermost what? Shell. But according to octet rule, first shell should have many electrons? 2, second 8, third 8, even the fourth shell can go up to 8 electrons. But this one we are having 2 electrons in the fourth what? Shell. So this shell is not stable. Therefore, calcium should lose how many electrons? 2 electrons for it to become what? Stable. So when it loses these 2, it's going to give to this chlorine. So let's do for chlorine now. So chlorine is Cl, and then it should have how many electrons? First shell 2. So 2 you subtract from 17, remain with how many electrons? 15. Second shell should have how many electrons? 8. So 2, 4, 6, 8. So 8 plus this 2, 10. You subtract from 17, we remain 7 electrons. So 7. So third shell should have how many electrons? 8 electrons as well, but it's having 7 there. So 2, 4, 6, then 7. So this shell, the third shell for chlorine, is not stable. It should have how many electrons? 8 electrons according to octet rule. So therefore this 1 electron from calcium, it will go here so that it can make this electron what? Stable. So I'm sure you agree on that one. Now why is this other electron going to go? Because for this chlorine atom, it's stable like this, because the third shell has become what? Stable. It's having 8 electrons. So 2, 4, 6, what? 8. Now calcium is made with 1 electron here, and this electron it must lose so that it becomes what? Stable. So have you seen these 2 down here? So which means we're having 2 chlorine what? Atoms. So I'm going to draw another one down here for chlorine. So Cl like that. First shell 2, second shell should have how many? 8 electrons, yeah? Like that, and then the third shell should have how many electrons? 7 electrons, like this. And then this other one will come here like that, as simple as that. So that's how you're supposed to do it. That's the reason we are seeing 2 here, which means you're having 2 chlorine what? Atoms. And then this side, you just have to show how this calcium will look after what? Losing, and how these 2 chlorine atoms will look after what? Gaining. So I'm going to draw for calcium. So Cl like that, and then I'm going to do that. It's having how many? 8 in here, like that. And then let me draw the other shell like that, like that, like that, like that, like that. So how many shells are here? 1, 2, 3. So let me write the other shell. Note that the fourth shell has been what? Lost, because the electrons, they are no more there. So like this. And then calcium is losing how many electrons? 2. So you can write to what? Positive, like that. Then let me do for chlorine atoms like that. There are 2, so you just have to show like that. So Cl, then I'm going to do this, going to do that, and then the last one like this. Let me do even for this one like this, like that, and then the last one like that. Then let me get the electrons like that, like that, like that, like that, like that, like that, and then A like that, A like that, like that, and then you show how it gained one like that. Then this one same, it gained one like that. So as simple as that, and I'm sure you're clear on this. So this thing is very much what? Simple. Like that. And then this one was gaining 1, so you indicate as a negative like that. This one like that. So this is calcium what? Chloride. So this calcium we are seeing here, and then these two chlorine atoms, that's why there is a 2 here, and I'm sure you're clear on this one. Okay, now let's do characteristics of what? Ionic what? Bonding. They are made up of positively and negatively charged what? Ions. So have you seen ionic bonding involves positively charged ions from what? Metals, and negatively charged what? Ions from the what? Non-metals. So they are made up of positive and negative charged ions. So it means what that means now. And then they are high melting and boiling what? Points, because of the strong electrostatic forces of attraction between the what? Ions. 3, they are soluble in water, so they dissolve in water, but insoluble in organic solvents such as what? Ethanol or petrol. So they can't dissolve in ethanol or petrol, but they can dissolve in what? Water. The 4th one, in aqueous solution or molten state, they conduct electricity because the ions are free to what? To move. So ionic bonds, they conduct what? Electricity, because of the ions that they are made up of, which are free to move. The 5th characteristics, they are non-volatile, meaning they don't have the tendency to vaporize, and generally solids at what? Room what? Temperature. So you need to know this, very much what? Important. Okay, now let's do for covalent what? Bonding. So the alternative term or the other name for covalent bonding is what? Molecular bonding. So what is molecular bonding or covalent bonding? So covalent bonding involves the sharing of the outermost electrons between non-metal atoms. So this one involves sharing of the outermost electrons between non-metals what? Only. Note that the outermost electrons are the one that participate in what? Bonding. Unlike for ionic bonding, which was involving transferring of what? Electrons from metals to non-metals. So you need to know the difference between covalent bonding and what? Ionic what? Bonding. So covalent involves sharing of electrons between non-metals only. Wow! Ionic bonding involves transferring of electrons from metals to non-metals. You need to know that. Example, illustrate the formation of covalent compounds that exist on the following given what? Molecules. So I'm going to illustrate for hydrogen molecule, also for water and what? Carbon dioxide, and I'm sure for ammonia you can do it on your own. So let me start for hydrogen what? Molecule. Okay, so let's do it. So what makes hydrogen molecule? It has 2 down there, so which means it's having 1H like that to form H what? 2. And then this hydrogen on the periodic table has what? 1 on top like that. So this one involves sharing of electrons. So let me do this now. So let me do this. This is hydrogen plus another what? Hydrogen. So how is this hydrogen molecule formed? So you know that hydrogen has 1, so it has 1 electron like that. Even this one, it has what? 1 electron like that. But according to octet law, first shell should have how many electrons? 2. Second 8, third 8, just like that. But first shell, hydrogen has just 1 shell. It's having 1 electron instead of 2. So which this one is not stable. Same applies to this one. it's supposed to have 2 electrons, but it's not stable. So what will happen is these two will bond, will start sharing these what electrons, and then hence it will look like this. So this is hydrogen, another hydrogen like that. So these electrons will be like that. So as simple as that. So this is hydrogen what molecule. So that's how we're supposed to do it. And then let me do for water. So water, what makes water? We have hydrogen and what? Oxygen. So we have 2 hydrogen what? Atoms. So what are we going to do here? So this is hydrogen. This is hydrogen. So hydrogen plus oxygen plus another hydrogen is going to form what? H2O, water. So let's do it now. So note that for hydrogen it has what? 1 like that. It has 1 electron like that. And then for oxygen, it's a symbol like this. First show us how many electrons. I'm going to differentiate by doing this process like that so that you won't be confused. Oxygen has 16. Oxygen is like this. It has 16 on top, 8 down. So I want just to show you where these electrons, the one I'm going to put here, which are 6, where they are coming from. So 2 from 8 remain with 6 electrons. 6 electrons. But have you seen that oxygen, this second shell, is not stable because it must have 8 electrons. So there are 2 electrons missing here. So and then plus we're having 4 hydrogen, another hydrogen here. Let me do this. So what will happen now? So these 2 we are seeing, it will bond with these electrons so that it can fill up this space. Because the way it is like this, hydrogen is not stable. Even like this, not stable, because first shell should have 2, and then it's having 1, so it's not stable. So this will start sharing what? Electrons. So it will look like this. So I'm going to draw for oxygen. Note that only the outermost electrons participate what? The electrons found in the outermost shell, they are the ones that participate in what? Bonding. So I'm not going to draw this second shell here, no. So I'm not going to draw the second shell here. So what will happen is this one hydrogen will come here, the other one will come here. So this is hydrogen. So hydrogen is having 1 vertical one, we are seeing. Even this one is having vertical one. So I'll get this one here, I'll put it inside here, the other one this side. So for this hydrogen, it has become stable. This one has become stable now because this shell now is having 2, this one is having 2, and then we are remaining with these other 4 here. So you can put anywhere here and here. Have you seen that they have shared electrons? Even oxygen has become what? Stable. So this is 2, 4, 6, 8. And then this second shell for oxygen has become stable, and then hydrogen has become stable. Even this one has become what? Stable. So this is what? Water. So that's how it is. Then let me now let me do for carbon dioxide. Let me illustrate for carbon dioxide, and then for ammonia you do it for yourself. So carbon dioxide consists of 1 atom for carbon and 2 atoms for oxygen. So it's going to be like this. So oxygen plus carbon plus what? Oxygen, which is going to give us what? Carbon what? Dioxide. Now this time I'm just going to illustrate the outermost what? Shells, because the outermost shells consist of electrons that participate in what? Bonding. So oxygen, the symbol is O. The outermost shell for oxygen, it has how many electrons? It has 6 what? Electrons. And I'm sure by this time you know what's happening. Carbon has 6 as the atomic number. So in the first shell there are 2 electrons, and then in the outermost shell we're going to have 4 electrons, and I'm going to differentiate with these stars. Here I'm going to put the dots like this so that you can see clearly what's happening here. Plus oxygen. So oxygen, the symbol is O, and then in the outermost shell for oxygen there are how many electrons? 6 electrons like that. So what's happening here? Have you seen this second shell for oxygen, it needs how many electrons? 2 electrons. There are 2 electrons missing here for it to be stable. And then carbon needs how many electrons? There are 4. It needs about another 4 electrons here so that it can be stable. This oxygen needs 2. So what will happen here is these things will bond, so that when these two and these two bonds together, this oxygen will be balanced. It's going to have 8 units of the molecule. And then this carbon, it's going to have, when it bonds with this one, it's going to have about 6 electrons. And then put this and this should bond so that it can complete carbon to be what? 8. As a result, you're going to have something like this. So we're going to have this for oxygen, and then we're going to have carbon in between, then we're going to have another one like this for oxygen. And then here we're going to show the electrons for oxygen, and then there's that one for carbon, and then here the stars for oxygen, and then for carbon, like that. Then so carbon is stable now, it's balanced. So 2, 4, 6, what? 8. In the second choice there should be 8 electrons, and then here there are many electrons here, 4. These are the ones like that. Then this one, there, just like that, 4 electrons. So it's stable now. So 2, 4, 6, 8 for this oxygen atom, and then 2, 4, 6, 8 for this oxygen atom. So it's stable. And then for carbon, 2, 4, 6, what? 8, like that. Then you are done. As simple as that. And I'm sure you're clear. So you can do for ammonia. Okay, now let's do the characteristics for covalent what? Compounds. So the characteristics for ionic bonding, I'm sure you can remember, it's just the opposite for this one. So they are made up of what? Molecules. And I talked about molecules. They have low melting and boiling what? Points, because of the weak forces of attraction which holds the what? Molecules. So it's just the opposite for ionic bonding. They are insoluble in water, but soluble in what? Organic what? Solvents. But for ionic bonding, they are soluble in what? Water. Just the vice versa of the other. They do not conduct electricity in solid or solution form, because they are made up of what? Molecules. So these ones, they do not conduct what? Electricity, because they are non-metals. And then they are generally what? Volatile. So they have a tendency of what? Vaporizing. They can vaporize so what? Easily. Examination questions. So you can do these questions on your own. I would have done them. Notice that the video is too long. Yeah, and most students, like they fail to concentrate when the video is just too long. So you can do this at your own time, and you can submit the answers. There's a number, there's a WhatsApp number down there. Then I'll be able to collect you where you are going to miss out. But I'm sure by whatever you have watched, you are clear about everything. And then there's another question 2, you can answer. So the other question, the first one, it was about covalent bonding, and then this one is about ionic what? Bonding, and I'm sure you're clear. And then last, you don't forget to subscribe, like, share, and what? Comment. And thank you for watching.